Hello guys, welcome to our course Python for Data Analysis, and in this video we'll be discussing about user-defined functions. We'll explore how to define and use user-defined functions to encapsulate reusable piece of code in Python. So before we get started, you know what to do. Don't forget to like this video, put your question in the comment section, and subscribe to this channel. Let's code.
9 to 5 data.
User-defined functions are functions that are defined by the user to perform a specific task or set of tasks. They allow us to encapsulate logic into reusable block of code, making our programs more modular and reusable, readable, and also maintainable. By defining functions, we can break down our complex problem into smaller, more manageable parts and then solve each part independently of the other. Let's go to our Jupyter notebook to explore some examples of user-defined functions in Python. User-defined functions in Python, the syntax is that you put a keyword def, def, followed by the function's name and the parameters you want to specify in the function. And after that, you can have docstring, like a document that describes what the function does. And again, then you have the function body, which is a code or statement to perform some tasks. And after that, again, you have a return statement, which is optional, but it is used to return a value or object. So the return statement returns something. Let's take some example. Let's define a function that returns the square of a number. So using the syntax, we start with a keyword def, followed by the function name. The function we want to do is square a number. So let's say square number. So the function name has to always be a snake case. So there shouldn't be space between your function name. So square a number. And we'll open and close brackets and also put the parameter, that is the function will always take a parameter, and the parameter is going to be a single value, and the single value will be what we want to accept. So for this point now, it's just a simple function where the parameter will accept a number and it will return the square of that number. So followed by a colon. And for the purpose of readability, you can put a document or an explanation of what your function does. So we do this and say returns the square of a number. So after that, so we then specify the task we want to perform, and the task we want to perform is square a number. So we can say square equals the value we take from the top, which is the parameter we specify at the top, and the square root of the parameter, which is asterisk asterisk 2. And then once we have this, we want our functions to return the square. So we just do return square. So once we run this, we don't get anything. We run this, we don't really get any results. So because we just define the function. So now let's test the function. So testing the function. You can say we want to print the results. So we can say square number so that's the name of our function, and we open bracket. Sorry, there's a mistake in the spelling. So we open bracket, and don't forget that our functions takes in a parameter, and the parameter is a number. So right now anything can be input, but it will lead to an error. So for now, we assume that the user of these functions know that, okay, it takes in a number, and for that we'll say we want to get the square of 4. So we just put 4 into these braces, and we'll run our function. So we'll get 16. We can try again with another number. So let's try square number and say we take in a parameter of 9. We have 81. So that is how the square functions work. So you can also maybe save the result into another variable, and let's say result equals, let's say, square number, and we put value of 8. So we can say print square of 8 is the result. And once we run this, sorry, there's a mistake in the spelling. Don't know why I keep getting the square spelling wrong. So square of 8 is 64. So that is just a simple function. So this time around we want to do a factorial function. So we do def, which is our keyword, factorial, and n. So then we'll do our explanation, which is using triple quotation, returns the factorial of a non-negative integer. So to do this now, the next thing we need to do is put in the code to perform our task, and we start with a condition: if n equals 0, return 1. So this is taking into consideration that if the number we specify is 0, we know the factorial of 0 will always be 1. So that is why we have put that condition to take care of that. So if another number was given, so else, then we'll do return and multiply by factorial minus 1. So we are reusing our function again. So that is what they call recursive in Python. So in further explanation, we're getting to know more about recursive in future videos. So for now, let's run this. And once we run this, nothing happens. So the next thing is to test our function. Test function. Test function. Results equals factorial, and let's say we want to impute, or we want to get the factorial of 5. We put 5 there, so we can print result and see what's the factorial of 5, and then we'll run this. So we get 120, which is the factorial of 5. So if you're a mathematician, you know the underlying mathematics formula behind the factorial. So that is, we just wrote a function to get factorial of a non-negative integer. So we can also have functions with multiple arguments. And let's give an example. You know, the ones we have been doing before is just a simple argument, like taking one parameter. So what if we have functions that can take more than one parameters? So, or functions without an argument at all. So let's take an example now. So let's define the functions to greet. Say greet. And now in the functions, we put a variable and set the variable to a particular value. Let's say name equals guest. Guest. Close that, colon. And if you want, you can give an explanation which greets a person So what the functions does is return the task we want the functions to perform, return hello, concatenate it with a variable name, and also do a concatenation to an exclamation mark. So let's run this function and testing the function now. So we can say print, let's print the function directly, greet, and close and open bracket. If we run this, so this will just output hello guest. So because we asked it to return hello plus the variable we specified initially, so we don't need to re-specify the variable again because we already put that, we already defined that when we were creating the function. So let's say we want to change the name. We can just specify the name we want. You can say we want to print Alice. So we want to print hello Alice. So just say print greet, the function, and the value we want to put in the name variable. So this time around, we are changing, in the initial definition of the function, the name variable as the guest value. Now we are changing it to another name. So when we run this, you get hello Alice. So we can always change the variable to whatever we want just because we have defined a variable at the initial stage. The way the function was built is that we define the function with a default argument name, which is having a value of guest. So it means that if no argument is provided, it will always default to what was given in the initial stage, which is the guest. So if we provide another argument, the function will return that argument provided. So that is why we have Alice when we put Alice as a new argument in the function. So that is all about functions. So we'll talk more about keyword arguments in the next video, and this will help us to build a more dynamic functions and a more robust functions that can perform any tasks. So don't forget to like this video, put your question in the comment section, and subscribe to the channel. Happy coding.